What's up, y'all? This is Hussein Nasser from iGeometry Podcast, and welcome to today's podcast, everybody. Please sit back, relax, enjoy this show. Today, we're going to discuss scalable software. So, when when uh, when someone asks you to build a scalable software, usually what comes to mind is too many aspects, right, to scalability and software. In general, scalability really depends on the requirements of the application itself, right? Because at the end, uh, every app that you design, you have to set some sort of what they call a service level agreement, right? So it's like if you expect, right? That's why when you build a scalable app, you think like in the beginning, I am going to build my app so that I'm gonna have a maximum of 5,000 users, all right? So, to serve 5,000 users, you will need X amount of resources, right? So you need this much machines, or whether you would need vertical scaling or horizontal scaling. And we discussed that, right? So, like my app will serve 2,000 users easily on for example, an 128 gig of RAM, 8 core CPU machine with SSD as a database, for example, right? So you think you'll put the resources required for your application, and then you set some sort of a threshold. Says, hey, uh, this is my service level agreement. They call it SLA, right? And try to meet that. So let's go deep and a little bit technically here. So if you build an application and as a single user, everything works great, right? Like even us developers, like when we build applications, let's take an example. How about that, guys? Let's take some examples. So let's say I'm building an application similar to Instagram, or let's say I'm building Instagram, but it didn't exist yet, right? So if I am building this app, right, and let's go dive deep into the weed and say, uh, to retrieve my Instagram feed, which is basically all the pictures that my following, yeah. So people I follow retrieve all pictures that have been posted by my following, that people I follow, right? So that query, you would think like would be a select picture from table, right? Give me all pictures, right? And you would try this app, and it will work, right? But let's say for a few users, like everyone posting 3 pictures or 4 pictures, and you'll end up with 100 pictures. That will work, right? That 100 picture will be retrieved, no problem. But as you start adding followers or following, and those people start adding more and more pictures, that query is not scalable, will not become scalable, because there are no filters, right? I said, like, give me all pictures, and that is really bad. So it might work for an application with 5 pictures or 50 pictures, but it won't work with a million pictures. So what should you do with this scenario? All right. So that query is called a non-scalable query in this case, right? You selected all pictures for all your followings, and as the number of followings and pictures increases, your app will basically proportionally degrade in performance, because you're gonna retrieve a lot of rows, a lot of pictures floating in the internet just to basically populate the feed. So that does not scale. That doesn't make any sense. Even if I open my Instagram feed, I do not look at millions of features at the same time, right? There is a feed, like as you scroll, you fetch more feeds, and that brings us to the solution to this, like a simple solution. It's basically use paging, where, yeah, this is an ultimate query, order by date, but what you do is you fetch page by page. So give me 10 pictures at a time. So the first query will retrieve 10 pictures, and what happens here, I will start scrolling up, and I see the first picture, the second, third, fourth, fifth, and as I reach the end, the Instagram or the app that I built will start sending, hey, this guy's about to about to browse the first page. Let me fetch the next page, the next 10 pictures. So you run another query which executes really fast, retrieves that 10 rows for you, and then start populating this feed for you, right? That, if you notice, like if you scroll on Instagram, it will start populating things as you reach halfway, or it depends on the algorithm, really. But that's the idea, right? So now this is like from a database or networking congestion aspect. But let's take the app. Okay, you implemented paging, right? And I'm really bored, right? Really bored looking at my Instagram feed. There are, like, I don't know, there are a lot of pictures. Like, so I started browsing through my feed, scrolling up. There's the 10 pictures, second page, 10 pictures, third page, 10 pictures. I'm still scrolling. It's the same app. Where are all these pictures loaded? Can you guess? You guessed right. They are loaded into the application memory. So they are in my phone. And my phone is this app is consuming RAM, right? Memory from my phone. And as I reach 60 pictures, 70, 80, 100 pictures, I mean, you go through the 100 pictures really quick, right? And all these pictures are getting loaded into the memory. So that, again, by the time you reach 500 pictures, all these 500 pictures that you already seen, they are, guess what? They are loaded in your memory, right? That is not scalable. So this is another kind of scaling. So that memory is not scalable in this case, right? Because loading this much pictures or rows into the same, even with paging implemented, that will definitely kill performance in the app itself. That's why Instagram sometimes becomes really slow, right? If you accidentally fetch so many pictures. So what happens here is, one solution to this might be coming in the next segment. Stay tuned. Yeah, so how can we solve this problem, the memory congestion problem? So I don't want to load this much pictures. If I looked into a picture, evict that picture or that row or that memory location or these variables, evict them from the memory and free up the memory so other people can use this locations, right? This is really critical, and this is like what these are is basically cache version of the of things, right? Where you will basically you're basically you'll basically load you will basically load these pictures into the memory, and what will happen is that as you start loading these pictures, the memory will get eventually it will get saturated. So what one solution to this is basically using what we call the least recently used cache. So as these pieces of information or pieces of data is no longer used, you can start evicting these pictures from memory, right? So you'll end up having only certain rows in the database, right? So that's the in the memory of the application. So that's the idea of one way of another kind of scaling, right? So what brings us like another type of scaling that I can think of is basically the actual call scaling to actually make a call and make that call scalable. So what does that mean? So let's take a step back and start to think here of another example. So let's go back to Instagram. I built the app, looks cool, but eventually what I did is I designed the application to run with this number of users. So my users started to increase, right? So I had 100 users, now I got 1,000, now I got 10,000, and all these users are hitting the same server now, the back end. Now I have to think about that. If all these users are hitting one server, eventually the amount of connections that I'm going to open will drain the memory of my server, the backend, correct? And what will happen in this case is my application will no longer be scalable at a back end level, if you think about it, and that is really critical because if one machine is no longer enough, right? So how do you scale in this case? You can either scale, you can ask yourself, can I scale by adding more resources to this? I can have one beefy machine, really good machine, and I just have it really, really strong, really beefy machine. And will it serve 20,000 users? You can ask yourself this. This is called vertical scaling. Another kind of scaling is horizontal scaling. So have this lighter machines, but horizontally scale them. So we do some sort of a load balancing between them. So you have more machines, cheap machines, but balance your request across all of these. So this is the end of this podcast, guys. Hope you enjoyed this episode. All right, sorry for the ums and I'm really driving here, but yeah. So what do you want to discuss next in the next episode? Let me know. All right, guys, enjoy. See you. Bye bye.